Good morning, good afternoon, good evening. My name is Joe Fish Kay. I'm Principal Research Scientist at Mozilla, and today it's my pleasure to introduce you to Ricardo Baeza-Yates. No, I got it wrong. Baeza-Yates, I'm sorry. I have known Ricardo for 10 or 15 years now, including time in which he was my grand boss. And one of the things that I think is really exciting about the work that Ricardo does is that it combines a very deep technical understanding of the issues that end up impacting us on an everyday basis, both as users of the web and as a company who is really actively trying to address that. But also these issues of bias and looking at how that bias impacts that experience. But what I like about his particular approach is because of this deep technical knowledge, there are other people who are working on bias on the web. There are other people who are working on these questions, and that's very important work. But very few of them come at this question with this deep technical understanding of the issues. And I think that's what's quite so important, both for Mozilla and for people working on the web in general. So I'm really excited by this. We'll take questions at the end. If you're within Mozilla, then we'll take them on Slack. You can join me on #speaker-series. Or if you tweet at me at @JoeFish, then I'll take questions on Twitter as well. If you're going to be either commenting or questioning on Twitter, then please use our hashtag Mozilla Speakers. That'll help us make sure we see what's going on and everyone else can see what's going on as well. So I'm very much looking forward to this. Ricardo, thank you very much. Over to you.
Oh, thank you, Joe Fish, for the invitation. It's a pleasure to be here talking about bias. The first bias you will notice is geographical bias on my background. So you will see different changes, and they are from a single country. So I have been talking about bias on the web from, I think, 2016, and this is an updated version of the original talk. And also I published an article in June of 2018 in Communication ACM that basically summarizes most of the content here, but there's some new content that is not there. And it's really interesting that when I finally came up with this talk, I realized that I have been working on bias for more than 12 years. And maybe even was trendy, and even people was talking about bias. I was interested in these deviations of systems and people in the web. So let's start with defining what is bias. So we have the same understanding, and there are many ways to define it. One possible one is to differentiate between statistical, cultural, and cognitive bias. So statistical bias is what we usually understand bias in science. So basically, you have a measurement, like here is like a normal distribution, and then there's an imprecision of the measure because of the measurement itself. But also maybe there is a bias towards the real value, and this will be the inaccuracy. For example, let's say you take your weight every day in a scale. Well, the scale may be 1 pound more, 1 pound less all the time because of this bias. Of course, you will prefer one of them in this example. Cultural bias. So cultural bias is all our background, and it's basically based on our education, the country we live, the language we speak is encoded in the language. I will mention a few examples later. And this is basically shared by many people that have the same culture. And the last one is cognitive bias. So cognitive bias is basically your own personal bias that affect your judgment. And there are so many that it will be very hard to have a talk only about that. But for example, these are the 20 top cognitive biases that can make your decisions wrong. And one is very important, is confirmation bias. So confirmation bias is something that you see that agrees with your values and your beliefs, and then you believe it's true only because it's basically confirming your beliefs. But of course, not always true, and this is the main reason behind the fake news. They exploit confirmation bias. But there are many more. There are almost 200 cognitive biases. You can go and find in the web is a codex of all possible bias. Even with different classes of them. And there's nothing wrong with bias. So we have a bias to think that it's something negative, but there's nothing wrong with bias itself. But we only talk about bias when it's negative, and we need to remember that. But there are many good biases. I mean, probably we are alive because of some biases that we have deep inside us in, for example, dangerous situations or other conditions. So what are the motivations behind this talk? So there are three motivations, and they're not in the order that basically motivated me, but I think this is the right order for the talk. So the first one is inequality of content, of course, in the web. And if we talk about that, we need to talk first about inequality of internet access. So for example, from 99% in Iceland to less than 8% in South Sudan or North Korea. In North Korea, it's even less, but we don't know exactly how much it is. Or content inequality across languages. I will not read all these numbers, but for example, most websites are in English, although it's not the language spoken by half of the humanity. Or things like Mandarin, for example, not the same number of sites with respect to English than to the people that live in China. And the same we can say for many other languages. For example, of the 7,000 languages that are alive today, only about 5% of them have a Wikipedia. So that's 95% of cultural knowledge and bias that is basically not being recorded. We will get back to this topic later today, but this is very important. The content in the websites is optimized for local purposes and not really for people. So they're optimized for government, for business, for education, but not really for what you need all the time. And there is a bias also on content quality, and I will mention a few examples later. So the second motivation is the impact that these biases on the web have on search and recommender systems. And you know, search and recommender systems are on mine research, especially information retrieval. And basically, the problem is that most web systems today are optimized by using implicit user feedback. Every click you do, every mouse movement you do, every transaction you make, it's basically as a signal for the system, and usually it's a positive signal. So basically, if you do something, that means that you are interested. However, then we are partly biased by the choices of these systems put to us. And I will get back to this because I think this is a fundamental problem on our system today, is basically exposure bias. You can only choose from a very limited amount of possibilities, and there are many, many more. And then you have problems with machine learning systems that basically find suboptimal solutions because they're watching this partial world. And this means that there are not only filter bubbles for people, but also there are filter bubbles for systems. And I will talk a little bit about that at the end. And maybe these systems are competing among themselves. They are learning basically how to beat themselves. That depends, for example, you have the same optimization function all across a company, or they're different depending on the role. And the typical example is, for example, user experience versus monetization. So a group is trying to get more revenue, another group is going to get more audience and more engagement. And basically, sometimes they're fighting each other because they are not having a consensus on what to optimize. And the last one has to do with this joke. So you will please read it. In this case, this joke is easy to prove that it's a fake news because there is some causality between internet and Einstein. So this is not true, he never said that. But many times it's much harder to know if it's true or not. And this is the last motivation, fake content and bias. For example, here you can see the traffic sources of this information in the United States. And according to Statista, is 42% coming from social networks, 30% is direct, 23% comes from search, and 5% come as a referral. And this is in 2017, and also things you can track. For example, probably the referral with things like WhatsApp, Messenger, Telegram, and other chat platforms is much higher today, but cannot be measured because you don't have access to the data. And the same you can get if you do, let's say, a survey. And here, for example, what people think, also from 2017, about if results of search are biased or not. And then this has to do with the spread of disinformation. I will not read these quotes, but here you have New York Times, Politico, or Stanford Internet Observatory. And here is, for example, again, data from Statista about who is responsible for spreading disinformation, like fake social media accounts, politicians, presidents, Russian government, and so on. So a lot of sources, and it's very hard, each day it's harder to realize what is true and what is not. And for example, the US government is moving to address bias in the network, and this was prepared before yesterday, that even you have more news about addressing bias in the network and also in social networks. And basically is the question at the end is who owns the truth? Who then has to decide that? The platform, or for example, the people reading the platform? And it's very hard to have a real answer, because in many topics, we know that we shouldn't trust the platform, in the sense that there are things that we cannot talk about, like, for example, Nazism or fascism. So after this introduction, I hope it's clear that human data has bias. And here I put observational human data, because of course, if you do an experiment with humans, you can get a different answer. But of course, you shouldn't do experiment with humans. And there are many documentaries about a few times where even some universities did experiment with humans. And I'm not talking only about, say, political issues. So which cultural biases are out there? So there are many. I will not read them. Here are the main ones. This is just my own list. You can put any topic and you will find some bias there. Statistical biases. As I said, this depends on the measurement techniques, but here in the web, for example, how you gather the data, how you crawl the data, how you sample the data, how much you use. You may have validity issues. For example, something was true 1 year ago, but today it's not true. You have completeness issues. Of course, you have noise, and you have a spam. And finally, we have cognitive biases. And I said before, there are 200 of them. We cannot put a list of 200, so we will capture all this in one main name that we'll call it self-selection bias. So basically, it's your own bias when you do things. And we will put all that together, and we'll get back to this later. So a lot of people have addressed the main cultural biases, like especially gender bias and racial bias. And for example, if you take Twitter data is biased to gender, more men. It's biased to age, towards people older than 30. Geographically biased, for example, in the US, it's geographically biased to where people live, like the East Coast and the West Coast. Educational bias, this is people typically have been through university. Economic bias, you need money to have a free time, a good smartphone, a good internet connection, and so on. And of course, you are a bit geek because you like technology and you like to be in Twitter, so you have this technological bias too. So for example, if you use Twitter data and you don't remember these 6 biases, then probably your result will only reflect the opinion of this kind of people, which is a minority in any country. And also remember that, for example, Twitter doesn't have a large penetration in most countries. So for example, 20% would be a typical one. So there is additional problems when you try to measure bias, and also when you measure it. And what I'm trying to do in this talk is an attempt of an unbiased personal view on bias in systems, in web systems. And of course, this is a personal view, so it's very hard to be completely unbiased, because one main problem with biases is that they are unconscious. We don't notice them when we make this, for example, a bias statement. So let's start with a non-technical question that has been very important in the last years, is that you have an algorithm, any algorithm, doesn't have to be an AI algorithm, but basically machine learning based algorithm will be the main issue here. because it depends on the data you use to train it. But you have biased data as an input, and then you need to ask the question, is this algorithm neutral? Is this algorithm fair? And the first problem is to define what it means to be neutral. For example, what means neutrality in Wikipedia. There's a lot of work going on that. Or for example, what is a fair algorithm? You know, fairness by definition is very hard to capture. So most of the time, computer scientists don't even make the question, and then they have the same bias. And basically, it's an example of garbage in, garbage out that is usually quoted. So you have wrong data, you get the wrong result. Now, one possibility to try to address what is being fair is to remember this nice cartoon coming from the web that basically shows an example of equality, equity, and justice. And this is the difference. So for example, equality, everyone gets the same, but then the child cannot see the game. Equity, you do some affirmative action, and that has been done with gender and minorities, and then you get some equity. But what we really want is to have just to remove the obstacle that makes necessary our affirmative actions. For example, remove gender bias, remove racial bias. And that takes a long time, and still we're working on that. Now, what is the answer then? Well, the answer is not always. It depends on what you're trying to do. For example, maybe you are trying to measure bias. And then, of course, you want to have the bias there. And also, the answer is yes, if you harm people. You need to take care of bias if your application will harm people. For example, if you are deciding if a person will get a loan in a bank, or for example, if a person will get a position in a company, and so on. There are many examples where it's not even ethical to use an algorithm, and we haven't agreed on that yet. So there are 3 ways to tackle the problem. These possibilities are debias the input, tune the algorithm, or debias the output. And we will not cover them here if this will be too much, but we will get back to this later. So very important, what we're trying to deal with here is bias awareness, because the first problem you need to solve is awareness. Okay, so in 2017, so a bit more than 3 years ago, the ACM US Policy Committee, where I participate now, did this statement about the 7 properties an algorithm should fulfill. Like, I will not read them, but we are talking about here about the first one. So basically about awareness. But there are many interesting ones. For example, accountability is a very important one. And for example, in Spanish, there's no word for accountability. We need to use 2 words. I think there is some bias in the language. And here we need to remember that systems do not need to be perfect. They just need to be better than us. So we shouldn't ask perfection. We should ask for things that are better than us. And basically, the problem today is that no algorithm fulfills these 7 properties. And not even one property is easy to fulfill. And this means to change the whole system of how we do software. So let's start with covering all the biases in the web. So the first one will be data bias. So data bias is what's encoded already in the data, and most data comes from humans, so this comes from us. The first one, the main one, is web spam, but we will not talk about web spam. So there's a lot of work on that, and maybe we will mention at the end, but that will be a different talk. We want to talk about biases that are more subtle, and you maybe don't know. So let's see a few examples. This one is economic bias in links. This is something that maybe you shouldn't do, but we did it in a study that more than 10 years old about basically comparing exports with number of linked domains from Spain and to Spain, so the exports. And basically you see here a correlation of 0.8. So basically you can infer maybe that correlation depends on the economic trade between countries, and that affects the links that you find in the web. So here you have some outliers like TK, TO, FM, TC, and you may look later where are all these places, but basically all these places are small countries or colonies that sold their right to use their domain name for, let's say, $50 million instead of using it because that was a way to get some money. We did the same with 5 countries, and we found that more developed the country, larger the correlation. So even there is a stronger signal that this is correlated to economy. Let's see another example of cultural bias in the web. So these are graphs of the size of pages in websites. And you see that they're very similar. The only difference is the average is a bit lower in Korea, in South Korea, and I will tell later why that happens. But basically here you see the famous minimal effort law of SIP. So basically, it's very hard to do a very large page. People will not do it. And also at the end, what you find is pages done by software, not by people. However, you see that at the beginning, there's another force that is opposing minimal effort, and I call it the shame law. So basically, you feel some shame of writing a very small web page, like 2 lines, 3 lines. This is 1,000 kilobytes, or maybe half a page. And then until when you reach like 1 page, you say, okay, this is enough. And then the minimal effort law kicks in. And this is a typical example of how we do work. We do work until we find satisfied, and then we try to avoid it because it's enough, right? And you find this everywhere. For example, in other measures. So the last one here is images in pages, and you see that you find the same. In Brazil, Chile, and Greece, you have like 3 images per page. In South Korea, you have 12, and this is a cultural difference. And this is why you have less text, because you have more images. Spain is like a special case because there are like only text in most pages. No explanation for that, but maybe it's another cultural difference. Let's see another example about a language. So this company, Language Connect, claimed that if you take the top 1 million websites, 55% of them are in English. We cannot check this list. We don't have the 1 million websites, and we can even argue what are the top 1 million websites, but I believe this is more or less correct. About half of the websites are in English. Now, what is the bias here? Well, the bias here implies what is the right reference. And many times in bias problem, we don't have the right reference. So for example, one reference could be, okay, let's take how many people speaks every language in a native way. So for example, English is number 3, yellow here. And of course, it's less than 10%. So the bias will be like 5 times more. Or maybe this is not correct, and we should take only the people that have access to internet. And then, okay, this is better, but then you have 25%. So still you have a factor of 2 bias between these 2 numbers. Or some people may say, well, but you shouldn't take what the people understand. You have to take what is the content of the web, and here we can argue. And if you take the content of the web, English is 27% of the content according to these statistics, and then again we have a factor of 2. So still we have a language bias. Let's take another example. This one is in translation. I'm sure you have used this many times. And for example, I will write, he's a babysitter, she's a doctor, translated to Turkish. I don't know any Turkish, so I cut and paste here, and I translate it back to English. And then, oh, now she's the babysitter and he's the doctor. So this is another example. Google fixed this about 1.5 years ago if you put just a single sentence. But if you put 2 sentences, it still was working a while ago. So you can try with your own language, also worked in Farsi. But what's the issue here? Why the gender was changed? Well, in Turkish, there's no gender in pronouns. So you see that here is obir, obir. So the translator cannot understand if this is a woman or a man. And then when we do the translation back, we get the opposite because the system has learned this from the text. The text is gender biased. Either if you take novels, news, doesn't matter the text in the web, you will find the gender bias in that, and there are many examples of that. And my last example is also about gender bias, but this is gender bias in content. This is from one of my former PhD students, Eduardo. And here is the biographies of women sorted by age in Wikipedia. You see that after maybe the French Revolution, so here we can do some historical inference, gender bias has decreased. So equality, egalitaire. And we are getting to almost 24%, 25%, still lower than, for example, 50%. So you can say, okay, there's nothing special here, there's just systemic bias, but the truth here is a much important bias that is hidden in the process, and of course will be obvious after I tell you. What it is? Well, most editors in Wikipedia are men. There's another bias here because you don't have to put your gender, it's not compulsory in Wikipedia, so maybe this number of women that write about people is biased to lower bound, but probably will be like 15%, for example, but 50% is very far away from 50%, and it's also far away from 24%. So clearly there's bias here, and we need more writers in Wikipedia that are women. Okay, that was the first bias, data bias. The second one, I call it activity bias, and this will be a participation bias according to Nielsen. Basically, we not do the same in the web. So there are some passive people that just look, lurkers according to Nielsen, and also there are some people that are active, but they do much more than others. So let's see how many active users, that maybe are only 10% of the users, produce 50% of the content. So we are asking about more like the democracy of the content. And we look at 4 different data sets, a small one from Facebook. And there we found that 7% of the people posted half of the content. And this is the meaning of this graph. 7% of the people do one half, and 93% of the people do the other half. We also look at the Amazon reviews. And in Amazon reviews, we found that 4% did half of the reviews, and 96% did the rest. And this is a large data set that has been collected by Stanford. And we look at that because we thought that was too much bias. How 4% of the people can write half of the reviews? And 1 month after we published this paper with another one of my former PhD students, Diego, we found out that Amazon started to sue fake reviewers. So this happened in October 2015. We published in September 2015. We don't know if because of the paper. We cannot prove that causality, but was after. This continued in 2016 and continued in 2019. And even if you go today, you will see more news about fake reviews. So be careful when you see too many 5-star reviews, especially if there are no other types of reviews. Then we look at Twitter. We were able to do this in a very large collection of 2011, 2009 that is available from the past. And there we found that 2% of the people did half of the tweets. There's nothing strange with this. It's called ego, the reason. Many people can have to wake up every morning and tweet something. And that's life, I guess. And finally, we use all the data from Wikipedia, which is available. All the access data to Wikipedia is available, all the logs. And there you find that about 2,000 people did half of the English Wikipedia, the first version. And maybe thanks to these people, we have a Wikipedia today, because no one contributes to something that's half is empty or half empty. You need to have people that at least see it half full. That's another bias, how you see things, half empty or half full. Another thing that we did with Diego, which I think was a very important question for me, is how much content no one ever sees, or very little people sees, like your blog. And I call this the digital desert. And from this study, we found two bounds. The upper bound of 31%, basically articles in Wikipedia that in 1 month were changed or were added, and then in the next month, no one saw, because this number will depend on the time period that you are studying. And also, we found that more than 1% of the tweets is done by people that don't have any follower. I don't know if these people understand how Twitter works, but this is like going to the Sahara Desert and scream. So maybe good for you, it's a cathartic experience, but no one is listening to you. So let's go to the third bias. Now we take data from the web, we run it through one of these nice systems, like a web search system or a recommender system, whatever you are doing. And then the first problem is sampling bias. I will not talk much about this, but if you don't do the right sampling, you will get the wrong result. And one of the main things is that how much data you need to sample depending on what you want to see. Because we are usually working with things that are very close to zero, and then when you have probability very close to zero, like probability of a click, then you need to gather much more data than, for example, the standard error formula will give you. That will basically not estimate well, will be a subestimation of the right sample size. And then you may have a bias that is added by the algorithm. And here, very important, for when I say algorithmic bias, I'm not referring about data bias. Some people get these two things together, and I think it's very important when you work about bias to have the source of the bias very clear. And for me, algorithmic bias is where the source of the bias is the algorithm itself, not the data. And I will mention a few examples. So let's start with the first example. Like this would be the extreme algorithmic bias. Let's say you have a system like Flickr where you can upload a picture and then write tags. So for example, you write London Eye and Thames, because this is a picture of London from the North Bank. And then you know about this thing, so you say, I will help people, I will write a nice quality filtering recommender system, and basically suggest some tags using co-occurrence of tags, and then I suggest these very nice tags that many of them are right. This is a very old example we did at Yahoo Labs. And then we can update the annotation. What's the problem with this system? The problem with this system is that people will use it. And then next time I will put only London Eye. And if I know a little bit about deep learning, I say, well, deep learning already knows all the tags. I don't need to put anything. And then I don't put any tags. I get recommendations. Even I say, okay, I don't need even to click in the recommendation. The system will come up with the right tags. What's the problem with this? Well, the problem with this is that this is a taxonomy. And a taxonomy can only improve if you have data coming from people. But basically, if the system is doing everything, there's no more data coming from people. And this is like a very slow harakiri, if you know this Japanese technique to commit suicide. So the algorithm is killing itself. So please, if you have a taxonomy, don't mess with it. Don't do this. This should be forbidden. But still, computer scientists do it. Delicious did this. That was a mistake. You need data coming from people. And then you need to live with minimal effort, not too much data. But that's the only way to do it. Now, you can use these tags for searching. So, for example, you can do for query expansion. This is a good use for this kind of thing. Okay, and then let's get to the main problem with algorithmic bias, and this will be a class of algorithmic bias. I call it interaction bias. So here, HCI people, please, this may be the most important part of the talk. It's for me. And here, of course, you have people interacting with this, and you have some self-selection bias between the people. So this is a combination of the bias coming from data, from the algorithm, and from you. So to make sure you understand this idea, please read this. And I want to pose a question now. I want to know if anyone can tell me what I like. And I will wait like a few seconds to see if someone can tell me what I like. In the meantime, I will change my background. So you have another view of the geographic bias. So anyone got the answer?
I noticed that I noticed it, but I want to see if anyone else did first. I'm not seeing it yet.
Okay.
Well, I hear that you love geography.
Yes. So this
I read very fast.
Yeah, you read very fast, but most people, even when they read very fast, will not read everything. And basically, this is just to make a point, a proof of what I will talk now.
We got 2 other people got geography, and someone else suggested Spain. So okay. We're getting there, you know.
Yeah, but the pictures behind me are not of Spain, so that was the wrong answer. Okay.
Okay.
So this is the problem. Believe it or not, the user design of the interface and the interaction itself has a lot of biases. And here you surely know this page is maybe an old screen for this page, but here I can show you all the problems in this page and in any other e-commerce website. So the first one and the main one is presentation or exposure bias. Basically, here you can see another bias. I like to play tennis and to watch tennis. And then basically, I'm seeing only like 3 items, or maybe 4 or 5. Do you know how many there are below? 10,000, 20,000? First, we don't know. And second, this is a very small fraction. It's not the tip of the iceberg. It's the ice cube on the top of the tip of the iceberg. So we are seeing just a little bit of all possible things you can see. Then you have position bias. So position bias is that you are basically reading this page, and because of cultural bias, if you're in the Western world, you will read first from left to right and from top to bottom. So the first thing you will look at is this corner, the top left corner. And then one particular case of position bias is ranking bias. So basically, you click more on number 1 only because it's in number 1, because the system is telling you that it's better. And you're trusting the system, but maybe, who knows? Another one is social bias. Basically, you will be biased to the judgment of other people, or even to your friends if you have a referral. Social bias is very strong. We do a lot of things depending on what other people think and not what we think. And then we have other interaction bias. For example, some people will never scroll and see the other items in this page. Or maybe some people have other issues like visual issues, like, for example, they are daltonic or they are dyslexic, and then they see things as you see. And one problem is that is a cascade of biases. So for example, here I have a list of possibilities. So presentation bias affects everything. Interaction bias affects, for example, click bias. There's some people that needs to click, and then this is not the system bias, it's your bias. And also people need to, for example, to move the mouse. So some people read moving the mouse. So this is another self-selection bias is coming from you. So here is the combination from the biases that come from the system and the biases that come from people. And here you can see this in practice. So these are some studies using eye tracking and a heat map. And you see that in 2005, most people will start in this corner. But when Google started with universal search and added other kinds of answers on the first page, then people started to look at images because images attract our attention. So you see that here, not only on the top left corner, but also on other things. Now, if you put this and see the data, this is an example of a typical click distribution, you will see that number 1 is like almost, in this example, more than 40% of the clicks. Part of the problem is what is called navigational queries. Navigational queries is part of your SIF law, of your minimal effort law. Instead of writing the website you want to basically look at, you do a search. This is about 15% of the queries today. Now, if we take this 50% out, we still have almost 30% here, which is a lot. And this is where the ranking bias comes. So this is the ranking bias. And here, in the position 10, you find another example of interaction bias. Some engineer in the first search engine, homework, what was the first search engine, decided that we need to see results 10 by 10. Why 10? Why not the side of the screen or whatever? Clearly must be an engineer, right? So that's another bias. Now, if we put this data in a log graph on the click-through rate value and in a linear graph on the rank, basically we will see something like this. We will see 3 different lines because of this interaction bias every 10 results. However, what we would really like to know is the true distribution, something like this, that doesn't depend on interaction and doesn't depend really on the order. So the first one doesn't get more clicks. And at Yahoo Labs, we published the only 2 papers known, as far as I know, that basically they bias these things. So not 2, 3. And one got the best paper award in Wisdom 2010, the last one. Now, there are other ways to deal with this. For example, you can, if you know a bit more, you can use machine learning to rank, and then you can put bias inside, and this was another best paper award from Cornell in 2017. Also, we have done some work with another of my former PhD student that now is in Spain, Carlos Castillo, and one of his PhD students on fair rankings. And why I put these 3 examples, because these are 3 examples of how to deal with the problem. So the first one is the bias the input. Okay, what are the right clicks? The second possibility is to tune the algorithm to deal with bias. This is the second case. And the last one is you can debias the output. This is the case of this fair rankings paper that I mentioned here. Okay, we are almost ending, and we need to basically to look at the final part, is the feedback loop to the system. And here you have 2 types of second-order bias, one that has to do with personalization and one that has to do with putting content back into the web. Let's start with that. So let's say you're writing your next blog entry. You know that content is redundant, and maybe you will find things that are correlated, but you don't care, you don't know. And then you create a new page, you search for something, you take 3 pieces of the first results. We have ranking bias. And then we put these 3 pieces on the new page. Of course, we are not doing plagiarism, so we will code this, put the author here, and put a link back to the source. So this will be like proper research. And now you feel some shame because nothing from you in this. Then you put some content here. So now it's nicely together, tight. And then you feel some pride, and then ego comes in, and you put your name. And then you publish this back into the web. What's the problem? The problem is that this content depends on the ranking function of this search engine. So basically, you are reinforcing the belief to this search engine that this content is really good, even if it's fake news. So in this paper that we published 12 years ago, and this was maybe my first bias paper with another former student, we showed that the redundancy was much larger. We found the ancestors of every web page, and that's why it's called the genealogical tree of the web. So basically, you have all these ancestors to a page, and then you can see from where something came. Okay, and what is the other case? Well, personalization. I don't know if you have learned about the filter bubble, but basically, maybe I know Joe Fish from a long time, but I will never be able to recommend something to him that is new to him because it's not in the data. And then he will love it, but it's new, so we don't know. But it's like this movie that surely you have seen this movie, maybe not read the book, but it's like the Truman Show. This person was very happy living in a bubble until he knew there was in a bubble. And then some people want to get out of the bubble. Some other people want to stay in the bubble. That's the problem. Solutions to break the bubble: diversity, novelty, serendipity. Even something I call my dark side. I would like to see the most different person from me when I'm watching news, not because I want to see the news of that person, because I know how far I am from people. because I think we have the bias that people is closer to us than we think, and the truth is that every election, I think, proves us wrong. So, and this is a very important corollary of what I said before. If people is in a bubble, then the system is also in a bubble, but it's a much larger bubble, but still a bubble. So if you do short-term greedy optimization, you have a partial knowledge of the world. Maybe you don't explore too much things that you feel that are not interesting, or you don't find the right people that will click in, for example, in an ad or buy an item, and then you never do long-term revenue optimization. And this has a very important impact in the long run, because basically you have unfair markets, and unfair markets are not healthy. And that implies that if you don't have a fair market, maybe in the future you will fail because you are basically working too much in the head of the distribution and too little on the long tail. And we have some early results. I hope to publish this result this year on basically that we need to explore more to basically do a long-term optimization. So we need to invest today to do better tomorrow, like most people do. And what we are doing in NTENT with this problem, we are launching very soon a news platform that basically tries to assess the credibility of the information, and basically to give just some awareness to people of if they have to check the facts or not. So we use 3 levels and many different algorithms, like here you have an example on the right. So it's a green. Green means that it's a well-written article and comes from a reliable source, and usually articles like this one are true. Still maybe some bias, but still the content seems to be truthful. You have medium credibility, the yellow ones, that basically are less reliable, and this article may be worth reading, but you need to be careful, because if you find that you agree with it, maybe it's confirmation bias and it's not really true. And basically the red ones these are like warnings. Maybe this is completely false, this is a fake news. And for example, here you can read the nice taxonomy of 7 types of disinformation that the first draft has. Okay, to end, the last 5 minutes, I'm sorry that it took longer than I expected. The web works thanks to bias. As I said, bias is also positive. Like caching works because of bias, because of activity bias, and because of your own self-selection bias. So what is the message? The message is that you need to be aware of our own biases. You need to stop this vicious cycle of bias in the web. And there are many research problems. If you're interested, you can contact me. I think there are many, many interesting problems here. Now, if we do like a recap, here I'm matching all these biases I mentioned to statistical, cultural, and cognitive. Seems that activity bias is all cultural and cognitive. What about the rest? The rest seems to have a statistical component, cultural component, and cognitive component. But what about algorithmic bias itself? If we have a system written only by women and another one only written by men, they will be intrinsically different? No one has done this experiment yet, and something that should be done by a sociologist. But we can look at this very interesting experiment done in 2015 by the Center for Open Science in Virginia, where they gave people all the data about the most famous soccer competition in the world, and they asked them, do colored players get more red cards than white players? Yes or no? So there is a bias or not? And this was answered by 29 teams with 61 people, so 2-3 people in average. And there was no agreement. 20 said yes, and 9 said no, we couldn't prove any bias. But the most interesting thing for me was not that they didn't agree. I think that almost is expected. The most interesting thing is that the 29 teams did something different. So here, if you know a bit about it statistically, there's the equally likely, the hypothesis line that shows that it's bias or not. And you can see that almost all the teams proved there was bias, but some of them couldn't infer it because the confidence level interval was too large. Even this one, that was the best proof for bias. Some groups didn't use confidence levels, so maybe they don't know what is this. how to do it well. But this shows the diversity of people. So next time that you have a very important problem, you need to have different teams to solve it, because otherwise some teams will work together and then they will bias it themselves. So independence is good to see different solutions. So what are my worries today? You can read the joke. It's not artificial intelligence. It's still natural intelligence, us. Why? Well, because otherwise this will happen. So the robot comes to the computer, says, prove you are not a human. And the robot says there are no more humans. And the computer says, correct. And they both laugh. And they will laugh not because robots kill humans, because basically humans kill themselves. And this is the problem today. So I hope suddenly we have an alien ship coming, like a rival, and then we have to talk, because that's the only way to survive. So while people think questions, I will put 3 quotes, which I think are very important for this topic. The first one is an attribution to a prime minister done by Mark Twain in his biographies, that there are 3 kinds of lies: dumb lies, and statistics. But Mark Twain was wrong in the attribution, so I guess this was a lie too, which is like a paradox. Something that in the 60s, a Nobel Prize of Economics said, torture the data enough and it will confess to anything. This is back to the example of the bias study. And finally, from Yuval Harari, the author of Sapiens and 25 Lessons for the 21st Century, the easiest people to manipulate are the ones that believe that cannot be manipulated. So next time that you watch something that you agree with, please remember this quote. So I can take questions or also biased questions, and in that case, please expect biased answers.
First off, Ricardo, thank you very much. That was super fascinating. I hope you can share the slides with us, because there's so much stuff in there that there's all these things that I'm like still sort of processing, things you said earlier.
Yeah, if you need the slides, I can share with all the audience too.
Great, that would be super. Send those along, that'd be super. We have a couple of questions. The first one is a very Mozillian question, but I think it's relevant to a lot of related stuff. At Mozilla, we often want to take a sample of web pages representative of what people visit rather than just what's out there. Starting with a list of the top domains, then considering only those sites' homepages isn't a very good method for that. And spying on our users, we also feel is a bit off the table, right? Like that's something that we don't really want to be doing. Do you have any tips? And I should mention that's from Felix Lawrence, who asked that particular one, who's one of our data science people in Vancouver.
Yes. So yeah, that's a very important question, because I think you are biasing the data to yourself. so you shouldn't do that.
I'm running with it, yeah.
So basically, you need to consider, for example, you need to find what is the right way to debias that. So basically, it will be similar to the click example. So basically, you want to see, okay, how much of the head I need to sample, and how much of the tail I need to sample, and how much of the torso I need to sample. That basically you have a much more fair distribution. In your case, may be very difficult to do because it's content and it's a bias to search and many other things. But you can do some A/B testing, basically changing the distribution. And basically, in some sense, if you change the distribution and what you get back later, what you see people seeing is basically the same distribution, that, like, let's say you have only a few classes, then you have the right numbers. So basically, it's like a 6-point algorithm where you find when you match the reality. And this will be very important, because then you can improve, for example, you can improve ranking with this in this way. So in some sense, what click the biasing does is improving ranking, and you should do the same here too. Other techniques to do it, I think it will be more costly, because maybe you need some human evaluations. But I think if you read the 3 papers I mentioned here about click debiasing, and also this idea of a 6-point algorithm that haven't seen it, that will be a nice study to do. You can get a much better sampling. At least you know in which direction you need to go. This is very important. Sometimes you don't know in which side you are biased. You know the side. You need to go more towards the tail.
Yeah, there's something nice about an answer which it relies on, like, great, okay, complete the feedback loop and then see if it looks like it's supposed to, right? Like there's something that feels like a good answer.
Thank you.
Another question here from Bianca. Bianca's in, well, usually she's in our Mountain View office. And she asks, what's the alternative to a folksonomy? Sorry, that she got it right. I always get that word wrong. I'm going to try again. What is the alternative to a folksonomy for the example of the image uploader tag system with the suggested tag? So if you put the tags in, then you introduce bias. What's a good way around that?
So there is no good way around it, but you can use the tags that I said to improve search. So because basically you are trying to enlarge your tag distribution to help other people, but the other way to do that is basically to use this as a query expansion technique to help through search. But if you help people to annotate, basically you are killing the folksonomy. Very slowly, but you are killing it. Now, you can always say, okay, we'll help people and only will use the data coming from people, but still the problem is that no much new data will come. And especially maybe in the cases that you want the data to come. So you're also biasing the process itself. So which images will get more tags or not. Maybe some images will get no tags at all. And then some classes of labels will be worse than other classes of labels. And also you don't want to add these kind of biases in your system.
One more question. This one is also from Felix Lawrence, our data scientist, one of our data scientists in Vancouver. And he asks, at some point, should you give up trying to debias your training set from the predictions of your old models and instead try and find other ways of optimizing the system? So artificially boosting products that you think would succeed to see if that boost ends up in model retraining feedback loop.
In principle, yes, but the question is that idea using data? And then if you are using data, we are back to the problem. So we have bias in data. So I would prefer something like my first answer, that if you can have like a fixed point algorithm where you can do like a small A/B test, and see what is the reaction of people. And of course, you can do this with also different samples of people, so you are not biased to a sample. Maybe you will see the right way to go. But again, I think that the first step is first to know if there is a bias. Second is to know the direction of the bias. So for example, in the example, you need to go more to the tail. And this is very important also when you sample query logs. I have a paper on how to sample properly query logs, not only the way to sample distribution, but also the way to sample the size, because this is very important. If you are looking for something that is not common, the size of your sample will be like 1 order of magnitude bigger at least, and maybe 2 orders of magnitude bigger at least than the standard error formula. So you need to be very careful. Many times people do the wrong sample, they don't see what they're trying to look for, and then they infer that that's not common, which is when you're looking for things that happen 1 every 10,000 times, 1 every 100,000 times, maybe you need to have like 100 million in the sample. But I have a formula, a corrected formula for that.
I'm going to dig up that paper. I look forward to figuring that one out. And I will put it on appropriate channels. I have another question that came in from YouTube. This is from the Divine Androgyne, Awakening LGBT. And they ask, question, what then is the most foolproof way to get to the closest thing to unbiased truth? Is there a way to validate source bias? For example, the Washington Post being owned by an Amazon owner would automatically note anything about Amazon having possible bias. So I guess this boils down to, do you believe that that the truth is out there, right? Do you believe that there is such a thing as unbiased truth?
Yeah, this is I'm a computer scientist, so let me disclose my limitations to answer this question. This is not a question for me, it's a question for a philosopher, right? I think first we need to decide the culture, so the answer will depend on the culture. I believe that for some things that are very basic, we can agree on some truths, like human rights. for example, is something that we have agreed that is true for everyone. But for example, of course, I think that in any media there's bias. So I don't believe in unbiased media. But the first thing is to acknowledge that bias. For example, to acknowledge somewhere says, remember, for example, in the case of Washington Post will be, remember, we are owned by Amazon, and disclose that. So if you disclose all your conflict of interest, this is the first step to address bias. If you don't disclose it, then I will say, okay, I cannot trust fully this information because they are not disclosing all their conflicts. We should disclose all our conflicts because even that may help us to find biases that we are not aware of. So I have done consciously that the last 3 years, and I have changed even my language with respect to gender, for example, bias, and try to be aware of things that most people are not aware of, and they appreciate it. Oh, I never noticed that I said that, because it's unconscious. And this is the main problem with bias. Another problem there is also related to the question is, do you want to fix that or not? I think this is the main problem. If some people like to have the bias because then bias allows to manipulate other people. But the question is why I want to solve it if with this way I have power or I have money or whatever.
Okay. So we're a bit over time, but I'm going to keep going because we have a couple of more interesting questions that I want to hear about.
I don't mind.
We're not that pressed.
Yes.
But so the first question is from Ian Wesley Smith, and he's a Mozillian who's at Pocket. I think he's in San Francisco, but I haven't actually checked. And he asks about mis and disinformation a bit. I mean, that's a topic that we've addressed in this speaker series before. We had some fascinating presentations from Kate Starbird, for example, and talking about some of the work that she's done on that. But this gets back to this same question. What can we do when people don't agree what is true, especially when we don't want users to end up in a filter bubble?
So these are very tough questions, good questions. One of the words of one of my former PhD students I mentioned, Eduardo, I want to mention this here, was, for example, to try to expose different views. Because when you try to expose different views and people are willing to read the other view, then maybe at least they will try to analyze the problem more objectively. And we found that was possible to do that using common topics. For example, maybe two people disagree deeply about an issue, but they love the same football team or the same basketball team. And they're willing to talk about this vis-a-vis or watching the game. However, we found that for politics, that was not possible. So for other topics, it was possible, but politics was not. So politics is like something very deeply rooted, and you see polarization everywhere. So I would say that if you try to expose other views, try to make people more aware, do interfaces that are more interactive. For example, I miss to be able to change the point of view in the interface. Like, okay, give me something more to the right, something more to the left. Show me where I am in what I'm reading. So feedback to the user. So give the user more control. Not all users are stupid, and that will help, because then at least some people will have more control on that. And especially if you believe this last quote, that if you believe that cannot be manipulated, you should be very careful, like trying to see, okay. I even believe that in the future, AI will help us with that. So we have like a system that will tell you, be careful, maybe here they're trying to manipulate. And also late in the night, the system will say, okay, you manipulated 2 people today. So if we have that feedback, I think that will be helpful. So please do systems with more feedback and interaction.
I agree entirely. I like that. So I have one more question. This is another question from Bianca. And this goes back to the very beginning of your talk, when you talked about web spam as having bias on the web. That obviously wasn't the focus of your presentation. Can you talk a little bit about that? What do you consider web spam to be? And can you elaborate a little bit on what bias exists there and how that impacts the web?
So web spam is basically all bias because it's content or links or even clicks that have an economic, basically economic, at the end, economic goal to divert traffic to your site, so you can have clicks for ads, and then you get money using that false attribution. So basically, for me, web spam is all this class of spam that has this goal of basically deceiving search engines and deceiving other systems to get people to click on the wrong place. Now there's a lot of work on that. There was a lot of work, especially on the 2000s, on how to detect link spam, content spam, and also like hundreds of papers on that. And I think that's at least I feel that that's already part of the system. So also search engines do a lot with web spam because also social networks like bots and all these. This will be for me also web spam, and it will be part of will be similar to web spam in say in apps, everything that is bots. So there's a lot of work on that, a lot of research, and I can do like a full talk about that, only that topic. So that's why I didn't want to get deep on that, because I think people also is aware of web spam, but I think people is not aware of almost all the biases that I mentioned in this talk. This is what I'm trying to do here. I like to make you aware that next time your system should consider these other biases that not only affect the minorities, they affect all people. This is also very important. Like interaction biases for all people, not only for some people like women or say minorities. This is the most important thing. Now we have a problem like interaction bias also affects people in different ways, like people with dyslexia or people with visual issues and so on.
Awesome. Thank you very much. If this was an in-person talk, you would be having rapturous applause right now, but unfortunately all you get is me saying thank you very much. But we really appreciate you coming. It's been fabulous to have the conversation. So
thank you, your fish. Thank you.
Very much appreciated. Thank you.